Space has to do something with precision. No one passed his time even for 1 minute. So the next speaker is Professor David Southwood, Director of Science and Robotic Exploration of European Space Agency, ESA. He has a PhD in physics from Imperial College, and he has more than 200 publications, scientific articles, which are not named now. Professor Southwood, please.
Well, it's a great pleasure to be here in Israel. It's also a great pleasure to have just seen the last presentation. The thing that isn't a pleasure is to try and follow it. That was, I mean, if you ever had any doubt that human beings should go into space, you take a look at that and you realize this is really beyond our planet. It is people working together from different cultures. And so I get the follow-up. Laurie said to me, "Oh, you're not going to cap this." So I'm not going to try. I'm going to tell you, though, about something that I regard quite as important as putting human beings into space, and that is doing science in space. For me, it underpins our capabilities in space. So I work for the European Space Agency. It's what we call a full-service space agency. ESA, whoops, I see how well I speak Hebrew. I read Hebrew. So right in the middle there, the S stands for science. And I've got to tell you, science is at the basis of all of this. You have to start from science, and you can go in two directions. In one direction, you get applications, and in the other, you go beyond. You go into exploration. But don't see these things as separate. In our agency, we see them as connected, and we see the use of space as connected directly to the inspiration that space gives. And the use of space, of course, is to explore the universe, but it's also everyday life. It's finding your way in your car with GPS. It's knowing that somebody is monitoring your environment, or indeed, it's using it to defend your country. And I think we, space people, need to be able to cross those barriers, to recognize that exploration, science, and application of space are all intimately connected. Okay, because I'm a European, so I've got we're number 2, I think. I'll concede that, Laurie. We're number 2 to the Americans, and I would like, it's very nice in a foreign country to say Europe actually owes a great deal to NASA and getting us into space. And when I talk about international cooperation, you'll see I emphasize cooperation with all sorts of countries because we take it for granted. We've cooperated from the very beginning with NASA, and that's with the United States. And I'm very happy to say that publicly. And indeed, if you look at the missions that we currently have in operation, actually one of those isn't in operation, Ulysses. We deliberately killed it. It overstayed its lifetime. It was circular, going around the sun in polar orbit. But it's there because it was the first time with the Ulysses spacecraft, which was to explore the sun and the solar poles. It's the first time we had a mission where we Europeans were the senior partner and the Americans were the junior partner. And That's not said in any patronizing manner. It just means we're growing up. We're getting up there, and partnership means sometimes one partner leads, sometimes another. And so we in Europe are immensely proud of this fact, that we are growing up. Once upon a time we had to follow Uncle Sam. Now sometimes Uncle Sam follows us. I'm not going to go through this full list of spacecraft I've got operating, because it isn't actually even the full list, because we also have missions we cooperate as minor partners with other countries. In fact, it shouldn't say double star, it should say Chang'e 2, which is a Chinese lunar mission that we're providing help with to the Chinese for. Double star is one we've just finished. We did Chandrayaan and future Chandrayaans with the Indians, and then we fairly routinely do missions with the Japanese and support them. And that red, white, and blue flag, anyone recognize that? It's France. And indeed, we Europeans are learning to cooperate with France. I can tell you, I heard that Israel is cooperating with France, and I wish you the very best of luck. I live in France, but you may tell from my accent, I really love it there. It's a wonderful country. Okay, I'm going to tell you a little bit specifically about Herschel and Planck. Those are two missions we launched on a single rocket. They've dominated my life for the last decade. I signed the biggest check I've ever will sign or have signed in my life to the contractors who built this. A few days, well, a couple of months after I became director 10 years ago, and it then caused nothing but trouble. My life was dominated by it. However, it's a little, I've never had a baby. My wife has had babies, and all the experience I have of having babies is from my wife's experience. All I can say is once the baby is born, really, it really is. You've forgotten. And that's actually how further babies ever get born, I think. And that's the same with these big missions. You slave away, you pull things together, you wonder really whether you'll be able to tackle all of the problems you face, and then when the data comes back, and you then realize it was worth it. And what I always say is the universe has to change. And just like when a child is born, the universe of the parents changes, I've got to say that's how it feels when you launch spacecraft. I'm not going to go into the technicalities of Herschel and Planck. Here is one of the headaches. They're two spacecraft designed to work at close to absolute zero. One only goes down to 1.7 Kelvin, that is 1.7 degrees above absolute zero. And the other one goes down to 0.1 Kelvin. That is very, very cold. It also requires an awful lot of technology and a terrible amount of sweating to get it down to that temperature. We say at 0.1 Kelvin, this is the coolest place in the universe. And it's literally true, because the universe actually does have a temperature. The temperature of the noise from the Big Bang is 2.7 Kelvin. And so both these spacecraft are cooled below the temperature of the universe. That's a tough call. But of course, why we're doing it is to look at our universe, and I'm afraid you have to look behind the light the universe itself emits to look at the light from the beginning. Herschel looks at the formation of galaxies, large-scale structure in galaxies, the formation of stars, and the formation of planets. I've got no shame in saying I don't mind people saying, how can you spend so much money? Couldn't you build a hospital? And I've got to say, you could build a very nice hospital for the price of Herschel. But frankly, it's still 50 cents from every European, every citizen in our countries. I don't think that's very much, but what I do think is you have to ask that it changes your view of the universe. Our payback is the discovery. It is to say, tomorrow we'll see things in a different way to the way we see it today. And we are looking at something that, when I began my career, we couldn't have known for sure. When I began my career, which was about 45 years ago, we didn't know for sure the universe began with a big bang. It did. That was discovered while I was probably doing my PhD. Yes, it was while I was doing my PhD. So I've lived with the Big Bang for a very long time. But that really opened up what science could do, because then we can use science to study the history and to understand where we've come from and potentially where we're going. I'm going to skip through to the scale of Herschel. Here you see it's a very large telescope. In fact, it is technically the largest telescope you can launch, because of the 3.5-meter mirror will just fit inside the fairing of the largest rockets. So we've got that record of having the largest telescope in space for some time to come, the largest monolithic telescope. And we're looking at the sky with that telescope with three instruments, three kinds of eyes that really open up new wavelengths. Our eyes are very limited. That's a very good thing, because, for example, all of you may not be aware of it, but you can't stop it. You're all radiating infrared light. So be very glad that your eyes can't detect infrared light, or you would be blinded just by the presence of all of us here. This is designed to look at that kind of light. And, just go back. Here you see the guys who built it. You see how small they are. It gives you some idea of the scale. And the thing I always say is, look, they came in through that door. They brought everything in through that little door. Now they put it together, and they realize they've got to get it out to take it to the rocket. Okay, we deal with engineering problems like that all the time. Okay, here I think is a quick movie just to give you some idea of how one puts things together, how complex, because this has got to be cooled, remember, to 1.7 Kelvin in its heart. And then what do? Put it on top of a great big explosive. I don't know. The launch is quite the most frightening thing. You then send it off somewhere beyond the moon to hang out there in deep space. This is a deep space observatory. And in fact, it's the new generation of deep space observatories looking at really the cosmos and where we began. Here are some of the first major scientific discoveries. It's the formation of Prestellar Cause, showing how they line up as strings that somehow have formed in the cosmic gas, the dust out of which stars form. You all look very attentive. Let me give you a shock. You're all stardust. You all came out of this, because up there, the chemicals, even the atoms that are necessary to make you, are being made. And that's one beautiful thing about knowing there's a Big Bang and so on. We can see the history, but we can look back and also see our history. I'm going to take you through some technical stuff, and I assure you, just look at the numbers. Read the bill, the numbers at the bottom. 600 to 2,000 gigahertz across there. Lots of lines. Now, I'm going to tell you what the lines are in a minute. Okay? Then we blow up just a tiny section, 480, 630, and there are even more lines. And then we blow it up again, 520 to 530, and even more lines. What's this guy doing? Just showing us lines. What are they? I'll tell you. Blowing up further still. Overall, we can get 10,000 lines, spectral lines. These are different lines of light coming from cosmic sites. We can look in tiny corners of the universe, less than a millionth of a degree across when you look up at the sky, but we can discriminate. These lines, what do they tell us? They're like fingerprints. There are some of the terrible things we found are up there. Hydrogen sulfide, methanol, hydrogen cyanide. That sounds deadly. Well, it is. It's poisonous. But I'm afraid sulfur dioxide, that smells bad. Methane also smells bad. This is chemistry. Isn't this why we turned over to do physics? No. Chemistry, it's also forming biology. The things that allow biology to happen down here on this planet, these things are being constructed out there in the cosmos. We're detecting them by detecting those lines. We're now no longer doing astrophysics, we're doing astrochemistry, which is when you start looking at the detailed structure of molecules. We're going beyond that into organic molecules, so we're going into biology. And you say, it's all out there. No, the results are back here in this room. You're all made of stardust. And for me, I have no shame about saying this is important to do. Absolutely, I feel this is something we all need to do, and it's the reason we need to do it in cooperation. I'm now going to turn to Planck. I'm not going to tell you very much about Planck, except it has a much wider field of view. It isn't even a telescope. With Herschel, you can go out of this room and you can log on the web and apply for time to point Herschel at some astrophysical body. You'll have a stiff competition whether you'll get the time, but you're allowed to apply for it. Anyone, any Israeli citizen is just as welcome as anyone else. Planck, however, doesn't give away time. It slowly rotates, scanning the entire heavens. Its aim is to see beyond all the material that Herschel is watching. Herschel is watching the early history, the formation of galaxies and the formation of stars within those galaxies. Planck ultimately is to go back to look at the Big Bang itself. In fact, only over the poles that's in the top and the bottom of the image can we actually see the raw noise of the Big Bang. And that's because we live on a planet, and that planet is in a galaxy, and that galaxy is surrounded by other galaxies, and indeed by clouds of dust, and so on, forming stars and galaxies. I'm glad that process is continuing, because somehow that process gave rise to us. What we're doing at the moment, and it is quite a task, is a decoding task to take away all the light that has been created since the beginning of the universe to get back to the original light of the Big Bang. And that's going to take us, now that took 14.5 billion years to happen. Please excuse us, it's going to take us 2 more years to finish the decoding. But eventually, we will have taken apart all of the galactic stuff to see right back to the Big Bang. Really, for me, this is very fundamental. The ripples, the tiny ripples that you look at in the radiation from the Big Bang, the noise from the Big Bang, is not uniform across the sky. And yet you would think with a Big Bang it should be uniform, but it isn't. Little tiny ripples. And those are the clues we have to follow to tell us that non-uniformity, it's like a seed. And out of those seeds, matter started clumping together to form first into the structures we know in the universe, the structures we know in our solar system, and the structures we know in our own hometown. All that came out of this. I can't do anything about it, but I can ask you to pay attention to it and make sure you study it. I'm going to skip along because of say one thing about our next mission. Our next major astronomical mission is to take apart our galaxy, Gaia, a 3D map of our galaxy. I've got a lot of other spacecraft under construction. And most important, we have cooperation with the United States, James Webb, cooperation with Japan, Bepi Colombo, and really something extremely important, the new Martian robotic exploration cooperations agreed between Europe and the United States. What I said to my counterpart in NASA, well, he said to me actually, he said, look, we can talk about cooperation. We can talk about how to bring the Russians in, how to bring the Chinese, how to bring the Israelis. But actually first, we've got to start cooperating. And so we, Mr. Weiler and myself, have put together an American-European cooperation. We're open for business for other people to join in, but we thought we'd better show we could do it first. And so I'm immensely proud. We've got a joint robotic exploration of Mars, and of course, as Laurie said, this has to be the precursor eventually to human beings going further and further away from our home in space. That's a cosmic vision. That's how ESA looks. We've got lots of missions coming in the future. We're about to go into a year of choosing what we're going to do, choosing between brilliant missions, all of which the requirement is change our view of the universe. Give us new information about the world we live in, and beyond that, the worlds beyond the world we live in, the worlds out there in the cosmos. I'm going to skip that. And finally, just want to say a little bit personal. It was very emotional for me to see when Timothy takes off from Baikonur in Kazakhstan. I was 12 years old when the Sputnik was launched from Baikonur. We didn't know it was launched from Baikonur. We didn't know where it was launched from, by the Russians. I can tell you, it frightened me. I'd always expected, well, I'd always hoped it would be the UK. I always knew it would be the US of A that would be first into space. That was a terrible shock to me. I was a patriotic Briton, and somehow Britons are always half American. And I have to say, that was a shock. But Timothy took off from there. I've launched several rockets. The first rocket I launched was from there with the integral cooperation with Russia, between Europe and Russia. I never dreamt that I would do it. And if you like, not only would the space science change the way we see our universe, really it's evidence also that the world can change, and indeed, although it always seems to be getting worse, it can get better. And I've got to say, Here is an example of a joint cooperation between the United States and Europe. The Huygens Corporation, this is one of the first images that showed as we descended onto Titan. Now, we Europeans descended onto Titan, but actually there was a mothership above us, and that was 100%, well, not 100% American, but very, very American. And we descended onto Titan. When I saw this image, I'm not as religious as my mother would have liked, but this was the point where, and I think it's okay to say in Israel, I said, thank you, God. Really, here we were entering a new world. We told everybody we would have a meteorology based on methane and so on, but actually seeing this new world. And one thing I am is, I had an English education, and we English aren't very, we're not good at speaking. We're not, I mean, if I can speak well in public, it's because I lived in America for a while. And that brought me out of myself. We English, we're poets, but we don't tell anyone we're poets, because if you tell someone you're a poet, you're asked to stand up and recite poetry. And that's absolutely, as a child, I absolutely didn't want to do it. On the other hand, the only way I could express the enormity of my feelings when we landed on Titan was with the poetry of an English poet, John Keats, from nearly 200 years ago. And this may be a little hard to translate because it is written in poetic English. Then felt I like some watcher of the skies, that is like an astronomer, and he was actually thinking of Herschel, because Herschel had just discovered Uranus. When a new planet swims into his ken, so this directly links to things in my life. Or like stout Cortez, when with eagle eyes he stared at the Pacific. This is crossing the Isthmus of Panama and seeing the Pacific. And all his men looked at each other with a wild surmise. Surmise is not a common word in everyday English, but it's hard to translate, to reword. But it's a wild feeling of expectation. Something magical has happened. It's a feeling that you've seen something you would never have expected to see. They never expected to see this great ocean. We never expected to see this new land. Silent upon a peak in Darien. Darien is the old name for the Isthmus of Panama. John Keats. Now, I learned that poem at school. I always tried to avoid reciting it. I recited it on television because I couldn't think of any words except ooh, ah, gee, wow. And I didn't want anyone to think I was American. So I remembered the poem. Actually, I did Google it, and I picked up the text. I really loved the poem as a boy. I recited it, and I attributed it to Percy Shelley. This is the way to get a lot of email on the internet from people. You may know a lot, you may be seeking the ends of the universe, but it was Keats that wrote that, not Shelley. I'm sorry. Anyhow, I think one last image. Again, this is a personal image. It's the image from the pole of Venus. The sunlight is taken in ultraviolet light. The night side is taken in infrared light. That's because Venus shines in, or reflects the ultraviolet, radiates ultraviolet, and radiates infrared by night. I had a great deal of difficulty in getting the Venus Express mission started, and I promised to do it in 3 years to prove we could do things faster, cheaper, and better. We did it in 3 years. But people always said, why are you going to Venus? Why not go to Mars? And I have to say, this image here, I knew why we were going to Venus. This image lays out something we suspected, but we didn't know. You can see there the vortical motions in the atmosphere of Venus. At the same time, you can see there is a massive, what's called Hadley cell. we had the meteorology of Venus laid out in one image. Again, I said, thank you, God. I don't know whether he heard, she heard, excuse me, Laurie. But for me, this was one of the great things about space exploration. It's about space science. It's about finding new things, things we didn't know, and also, quite shamelessly, things, I think, in many different ways. All of these things came out of international cooperation. All of these things link the science, the physics of Venus, the chemistry of Venus, the chemistry of the clouds that Herschel looks at, or the physics of the Big Bang. All of that links back to life here on Earth, because you all came out of it, but also the technologies, and I think I come back to the title of this meeting, all those technologies are very important for looking at our Earth and also for our daily security. And I think every space scientist needs to make this link from the cosmic to everything in daily life. And just remember, you can apply what you've discovered wherever you can. And that really means be alert to how the world works and how you can help the world work. Thank you very much.